Hello friends. Today we are going to do a very important theorem on circle. So the theorem is the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So now here we need a circle to prove this theorem. Suppose let's make a circle. Let's make a circle, or we can make it a little bit bigger. Suppose this is a circle. This actually doesn't look like a circle, but this is a circle and with a center, and make it a center and center O. This is the center of the circle, and what the theorem states: the angle subtended by an arc at the center is double the angle. Now let's take an arc on any area. Suppose this is one arc. This is arc and you can name it as BC. This is the arc. So where is the angle subtended? Here. Now this is the angle subtended. This part is the angle subtended by which arc? This arc BC. This arc BC. Okay, and you can name this circle O, center. This is the center of the circle. You can name it O. Now this angle is the angle subtended by this arc BC. Now what we have to prove? At the center is double the angle subtended by it at any point on the remaining part of the circle. So on this circumference, take any point. Take any point. For example, we take a point here. You name it as A. So what you have to prove? That the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So what you have to prove? This angle, the angle at the center, this is the angle at the center, subtended by this arc BC is double the angle at any point. That means we have taken A as a point. That means this angle is double the angle of this one. For example, if this angle is X, this is 2X. Y, 2Y. So here you have to join. You have joined AB and AC. Now this is your complete diagram, and you can start proving that this angle at the center. Now what is the angle at the center? Now clearly angle BOC. This is the angle at the center, and what is the angle at the at any point in the circle? A we have taken as a point A on any part of the circle. So this will be the angle at the, you can call it angle at the circumference, or now we have to prove that this angle is double, so double of this angle according to question. Now both stands on the same arc, standing on the same arc, and here we have two angles. Now we have to prove the relation between these two angles. When they stand on the same arc, the angle at the center is double the angle at the circumference. So what you have to write? Given a circle with center O. Now here a circle is given with center O, and angle BOC and angle BAC are two angles given. Angle BOC is the angle at the center. Angle BOC is the angle at the center. Now, if angle BOC is the angle at the center, what is angle BAC? Angle BAC is the angle at the circumference. Angle BAC is the angle at the circumference. Now we have to prove when this angle are subtended by the same arc, that is BC, both angles stands on the same arc BC. Now what you have to prove? You can make constructions from this point A. You have to join AO and extend it up to certain length. So okay, let's join A O and extend it up to D. Extend up to here, up to D. Okay. A comma O is joined and extended up to D. Construction what you have done, AO is joined and extended up to D. Now to prove, what we have to prove now? To prove, what you have to prove, as the question say, that the angle subtended at the center of the circle standing on the arc BC is double the angle at the any point in the circle at the circumference. So this relation between these two angles standing on the same arc, what you have to prove? Angle BAC, relation between these two angles. This angle is double the angle of this one. So what you have to prove? Angle BAC, not sorry, BAC. Angle BOC, this angle is double the angle, this is equal to angle BAC. Now we have to prove, because the angle at the center is BOC, double 2. The angle at the center is BOC and the angle at the circumference, any point in the circle, is angle BAC. We have to prove angle BOC is equal to twice angle BAC. This angle is double the angle of this one. So let's start proving it now. Now see in this triangle, in triangle AOB, see in this triangle AOB, now see here, this OA and OB are equal, right? This OA and OB are equal. What is the reason? OA and OB are equal because they are radii of the same circle. OA is the radius of the circle, similarly OA is the radius of the circle. So radii of the circles are equal. So in triangle ABO or BOA, in triangle BOA, what are equal? OA is equal to OB. OA is equal to OB. Reason? Radii of the same circle. Radii of the same circle. Radii of the same circle. Now see here. The properties of triangles now. If two sides are equal, if two sides of triangle are equal, then their base angles are also equal. For example, see this triangle AOB. Now I will make it a part of this triangle outside this circle. Suppose this triangle is like this, OAB. This triangle is like this. Now for example, two sides are equal. OA is equal to OB. The properties of triangle. These two sides OA and OB are equal, meaning their base angles are equal. What are their base angles? Their base angles are this and this. That means these two sides are equal. That means their base angles on the base angles are equal, meaning this angle and this angle are equal. So here what angles are equal? This angle is equal to this angle. These angles are equal. Now what is the this angle? Angle OBA is equal to angle OBA. The name of the angle OBA is equal to this angle. What is the name of this angle? Angle BAO. Angle BAO. What is the reason? These base angles of the triangle. Base angles of the triangle. Now these are equal. Now similarly here, check the next triangle. This triangle, triangle COA. In triangle COA, again OA and OC are equal. This part and this part are equal. The reason is same. Why they are equal? OA is also the radius of the circle. Similarly, OC is also the radius of the circle. So the reason is radii of the same circle. Right. Again in triangle AOC. Again in triangle AOC, what we can write in triangle AOC? In triangle AOC, OA is equal to OC. OA is equal to OC. Reason same, radii of the same circle, because they are the radius of the same circle. Radii of the same circle. Radii of the same circle. Again, if this radii of the same circle are equal, then their base, if two sides of the triangle are equal, then their base angles are equal. That means what are the base angles? This one and this one are equal. So I will take out this diagram. The triangle is also in this form. AOC. O, A and C. So as I told you, if two sides are equal, then their base angles on the base are equal. So these angles and this angle are equal. Similarly here, this angle and these angles are equal. So what you have to write? Angle OAC. Angle OAC equals to this angle. Angle ACO or angle ACO. Reason? Base angles of the triangle. Base angles of the triangle. The reason is base angles of the triangle. So these 2 points are very important in doing further statements. Now check. Now in this triangle, especially in this triangle, in triangle especially this triangle, triangle BOA. Now this is the exterior angle because it is outside the triangle, right? This is the exterior angle, it is outside the triangle. So what you can write in triangle, now I will tell you the basics of this properties of relation between exterior angles and interior angles. The formula of finding the exterior angles. The formula for finding the exterior angles, exterior angle is equal to the formula. Exterior angle is always equal to sum of interior opposite angles. Sum of interior opposite angles. This is the basics that you have already done. Exterior angle is equal to sum of interior opposite angles. Now in this triangle BAO, in this triangle, see, just in this triangle BAO, this is the external angle. So how do you find it? External angle is equal to sum of interior opposite angles. So what is the opposite? What is the two interior opposite angles? The opposite to this, there are two angles. This angle and this angle. This is the exterior angle. Opposite to this exterior angle, there are two interior angles. This angle and this angle. So using this formula, exterior angle is equal to sum of interior opposite angles. You can write. Therefore, from which triangle? From triangle BOA. From triangle BOA, what you can write? From triangle BOA, this exterior angle. What is the name of this exterior angle? This one, angle BOD. Angle BOD equals to sum of interior opposite angles, these two, right? These two. So what is the name of this angle? Angle OBA. Angle OBA plus, and what is the name of this angle? Angle BAO. Angle BAO. So what is the reason for writing this? As we have learned, exterior angle is equal to sum of interior opposite angle. This is the exterior angle and these are two interior opposite angles. We have to find the sum of them. So the reason will be the same. Exterior angle, the same reason. Exterior angle is equal to the sum of interior opposite angles. Exterior angle is equal to the sum of interior opposite angles. Okay, now, or angle BOD equals to angle OBA plus angle BAO. Angle OBA is equal to angle BAO. Now tell me, Angle OBA and BAO, what is the relationship? Angle OBA, what is the meaning of angle OBA? That we have already found out here. Check it. Angle OBA means, what is angle OBA? Angle BAO. That means we can replace angle OBA by angle BAO, that we already proved before. So angle OBA, you can write angle BAO plus and angle BAO, angle BAO, or angle BOD equals to, when you add this, it is twice angle BAO. So this is equation number 1. This is equation number 1. Now let's erase these statements. Now again, by taking this triangle, we got equation number 1. Now take another part of the triangle, that is this one. Triangle, what is the name? Triangle AOC. You take this triangle and find equation number 2. So from triangle AOC, again the same properties. Look at triangle AOC properly. Triangle AOC means, I will make the diagram here. Okay, this is AOC, for example, AOC. Okay, now this diagram is like this. Now here AOC and the name is D. Now check here, there is external angle. This is the external angle. This one is the external angle. Again the same property. External angle is equal to sum of interior opposite. What are the two opposite interior angles? This and this are the two interior opposite angles. That means external angle is equal to sum of two interior opposite angles, meaning this one. Angle DOC is equal to this angle plus this angle. Right? This angle plus this angle, same way. So external angle is angle DOC. External angle DOC equals to this interior opposite angles. So what is the name of this angle? Angle CAO. Angle CAO. These angles and this angle, as I have done here clearly, because it is a bit clear. So what you can write now? Angle, this angle plus this angle, OAC. Angle OAC plus this one is angle OAC, and now this angle. What is this angle? Angle ACO. Angle ACO. And the reason is same. What is the reason? Exterior angle. Exterior angle is equal to sum of interior opposite angles. The reason. Now, or angle DOC equals to, or angle DOC is equal to, now this is the most important part. Angle OAC, you can write it as it is, plus now angle ACO. What is the meaning of angle ACO? What we can write? We have already derived, we have already proved. Angle ACO, now check, angle ACO means what you can write? Angle OAC, that I have already marked with the asterisk mark before. Angle in place of angle ACO, you can write angle OAC. So replace the value of angle ACO by angle OAC. Angle OAC. So, or angle DOC equals to twice, when you add this twice, angle OAC. Now this is equation number 2. Equation number 2. Now you have two equations, equation 1 and equation 2. So what is your equation number 1? Angle BOD is equal to twice angle BAO. This is equation number 1. And just now we have derived equation number 2. Angle DOC is equal to twice angle OAC. So now what we have to do with these two equations? Now we have two equation 1 and 2. In equation 1, BOD, so adding equation 1 and 2, adding equation 1 and 2, add equation 1 and 2. What is your equation number 1? Angle BOD is equal to twice angle BAO. BAO. This is your equation 1. Now equation 2. This is 1. And what is equation 2? What is equation 2 just now? Angle DOC. Angle DOC equals to twice angle OAC. This is equation number 2. Now add this. Now we need to add this. Now tell me, angle BOD plus angle DOC, check your diagram. Angle BOD plus angle DOC. BOD, where is BOD? Angle BOD, this angle, plus angle DOC. DOC, this angle. Now when you add these two angles, you get one greater angle, right? This part. Angle BOD plus angle DOC. DOC. When you add these two smaller angles, you will get a one greater angle. And what is the name of that greater angle? Angle BOC. So here you get angle BOC equals to, now two angle. Now you have to add this, two angle BAO plus two angle OAC, or angle BOC equals to, come on to here, angle BAO plus angle OAC, or angle BOC equals to 2. Now when you add these two angles, see the diagram, angle BAO. Angle BAO is this angle, and angle OAC. OAC is this angle. Again, when you add these two smaller angles, you will get this greater angle, this. So what is the name of this full angle? The name of this full angle is angle BAC. So when you add this, you get angle BAC. So this is what you have to prove. This angle BOC, the center angle subtended by this arc BC, and this angle BAC is angle at any point in the circumference of the circle subtended by the same arc. So the relation between these two, we need to prove that the angle at the center is twice the angle at the circumference, which is proved. QED, proved. Thank you. Thank you.